So, Surya, what you send, that is the, I think the ionic equilibrium you said, the acid base concept. Yes, yeah, no.
It was acids and bases, I think.
Okay, that comes under the ionic equilibrium. So let's try to have the acids and base concept. Okay, acids and base concept. Okay, in the lower classes, how we define the acids and base, that is acids are, you say that is source to taste and bases are bitter to taste, like that. This was the earlier classes. In the lower classes was the definition, okay, on the basis of the physical taste. Okay, now here when you talk about the definition here, the in higher classes the definition of acids and base are the very different. Okay, even for the salt is also different. So if you talk about the acid base concept, they are broadly classified into three categories. Okay, the first category is, if you talk about, that is Arrhenius concept. Okay, this is the Arrhenius concept. Another one, if you talk about another one, this is the Bronsted concept. This is Bronsted and Lowry concept. Lowry, Lowry concept. Generally, it is only called at Bronsted concept. And last one is Lewis concept. Lewis, Lewis concept. So first of all, if you talk about the Bronsted concept, what is this? Is the basic clue is what here is the based on, if I'm writing based on H plus and OH minus ion in water. Okay, that is what the punchline of this one, that is it is based on the H plus ion and OH minus ion in the water. If you talk about Brown state, based on only H plus ion, based on only H plus ion. Okay, no water required, water condition is not there, water is no water required, means it is not compulsory condition that water required. Lewis concept, this if you talk about its punchline is based on lone pair electron. This is what, based on lone pair electron. Okay, so first of all you try to understand, they are the three names are there. First one Arrhenius concept, second one is the Bronsted and Lowry concept, and last one is the Lewis concept. So first of all, what we are going to do, we are taking the one by one and we are starting the study of this one. Okay, so let us see, that is Arrhenius concept. And in the Arrhenius concept, I'm writing Arrhenius acid. Okay, so Arrhenius acid, if you are writing the substances, they are saying the substances which gives H plus ion in water, which gives H plus ions in water, H plus ion in water. Okay, the substances which gives H plus ion in water are known as acids. Okay, that is what, any of the substance which are capable to donate H plus ion in the water, that is what is going to be the acid. Now the point which we have to keep in mind here, you know, that is the note. In the term of note, you can write here H plus ion in water. They are saying H plus ion in water is unstable. Is unstable. Okay, is unstable. So it combine. What it is going to keep? So it combine with other water molecule, other H2O molecule to form hydronium ion. This is what the point, to form hydronium ion. So simply, if you are talking about H plus ion generally do not exist. We write that is okay, but it exists in the form of H2O. Okay, I'll explain it in the detail. See, if I'm talking about HCl, so if you dissolve in the water, if you take the water, here is H2O is there. So what it is going to give? It is going to give H plus ion plus Cl minus ion. Okay, this is going to be aqueous and this is also going to be aqueous. Yes, yeah, no?
Yeah.
If you are writing this equation in different ways, see, HCl is there, and if you are putting that is HOH, this is water. So this way also you can write. How can we write? H3O plus, and plus we can write that is Cl minus. It means C. This is the how it happened. So if in the water molecule there is the two lone pair electron, if you have the concept of the chemical bonding, you must be knowing that is water molecule is having lone pair electron. Yes or no?
Yeah.
And out of HCl, out of HNCl, which is more electronegative and which is electropositive?
So out of HCl, H3O is
No, no,
H
out of
is
this one
sorry,
only, HNCl, which is negative,
H is
electronegative.
so Cl is going to be more negative and H will be more positive.
Thank you very much. So Cl is partially negative and this is partial positive. A lone pair electron can attract the proton, yes or no?
Mm-hmm.
So it is going to form that is H3O plus, right? So it is H3O plus and Cl minus. It means HCl gives H plus ion to form H3O plus. So it is acid. HCl is, you can write that is acid. Why it is acid? HCl is acid. H, it gives what? H, it gives H plus ion. Yes or no?
Yeah.
So this is the first one. And the R1, did you understand this one, R1?
Yeah. So
See, it's very simple. H plus it is going to give, if you are having that is water molecule H, O, and here is H is there. So you can see this is the lone pair electrons are there. So what is going to happen? This lone pair electron can attract this one. So lone pair, because H plus is having no electron. So what it is going to do, it has to form the bond. So how the bond is forming? You see H, here is O, here is H, and both the electron belongs to what? That is this one
oh, okay,
oxygen, so
okay.
it is going to form coordinate bond. So since electron has been transferred here, oxygen to H plus, so it is going to be O plus. So or you can write that this way also, you can write H3O plus. Yes or no?
Mm-hmm.
This is what is known as hydronium ion. Hydronium.
Okay.
So this is the concept of Arrhenius Base. Will you be able to understand this?
Yeah, I got it. Yeah.
Okay. I'm erasing this one. Can I erase?
Yeah.
Okay, thank you. So if suppose I am asking question, I'm giving you, right, and write this way, right? Dissociation of, right? Dissociation equation of following, the dissociation equation of following Arrhenius acid,
Mm-hmm.
Arrhenius acids. This is they are asking. So here the questions are there. Here is the, we are having HCl, then you can write that is HBr, then you can write H2SO4, then it is the HNO3, uh, this one. The next one is HClO4, then they are saying that is HSO3, H2SO3,
Mm-hmm.
etc. They are asking to write the equation. Okay, so you got to know what are the Arrhenius acids. Can you please write down this one and tell me?
Yes.
Hmm.
So
So HCl already we do. HBr already same way. H2SO4. See how the H2SO4 is there. H2SO4. Okay. It is the two-step process. This is the diprotic acid. I will tell you later on. So it is going to give that is 2H plus SO4 2 minus. Okay. So this is going to be acid. Why it is going to be acid? H. It gives H plus ion. Yes or no?
mm-hmm.
Hmm. So this is what is this one. If you are talking about HNO3, so HNO3 also it is going to ionize, this one going to be give H plus ion, NO3 minus ion. If you are talking about HClO4 minus, so it is going to also ionize, so it is going to H plus ClO4 minus. It is called that is chloric acid, perchloric acid. Okay. And if you are H2SO3 is there, okay, So the same way it is going to ionize. This is H plus. Okay, simple. You can take 2H plus plus SO3 2 minus. Okay, this is what. This is what is known as sulfurous acid. PHUROUS. Sulfurous acid. And
So the
4 is there. This is what is known as sulfuric acid.
okay, so the dissociation equation for H2SO4 is going to be 2H plus and SO4 2 minus.
Yes.
Okay.
Hmm. Acha.
So
What there the point is there H plus ion is equal to, if you are writing H plus ion is equal to going to be H3O plus ion, right? There is no difference in H plus ion and H3O plus ion, because H plus ion do not exist generally in the water. In the it's said that is it is supposed to be unstable, so it always combined with the water molecule to is present in the form of H3O plus ion. Is it okay?
yeah,
Okay. Can I erase this?
1 second. I'm just writing it down.
Okay, no issue.
Okay, noted.
Okay, thank you. Now, if you talk about the next one, if you talk about the next one, we are going Arrhenius base. This is Arrhenius base. This very simple definition. The substances, they are how defining the substances which are the substances which are capable to donate OH minus ion, that is known as hydroxyl ion. That is hydroxyl ion, OH minus ion in water. Here condition is there, in water is known as what? Arrhenius base. So that is if donating H plus ion, acid, OH minus ion, that is going to be the base.
So
Example,
the
you can
previous
write.
one was Bronsted-Lowry, right?
No, this is the Arrhenius only. Bronsted concept is different. Just after
Okay,
that.
so
Hmm.
I just have a quick question. So an Arrhenius acid is one that is basically when it dissociates, it forms H plus ions, and Arrhenius base is one that basically will donate OH minus ions when placed in water.
Yeah. In water, here water is required. But in case of Bronsted, you see, here what we wrote, Bronsted, based on only H plus ion. There is no OH. There is no condition for OH. Only H plus ion. And here no water required. Here condition is there. Water may be there, may not be there. If water, okay, that what the concept said. So KOH is there. MgOH here is twice is there. No, CaOH twice is there. Okay, BaOH twice is there. Okay, AlOH thrice is there. Okay, uh, etc. There are a number of the example is possible. So let's see. NaOH is there. So what you need to do here, this is the solid, salty, or anything you can write, that is okay. But if you are writing the NaOH, if you are dissolving in water, what it is going to give? It is going to give Na plus ion that is in the aqueous medium plus OH minus ion that is also going to be aqueous medium, right? If you are taking that is KOH, so what it is going to be there? It is going to be K plus, this is in the aqueous medium water, OH minus ion, okay. Now another is there, we are having MgOH whole twice, okay. This is, so it is also going to give that is Mg2 plus, this is again going to be aqueous medium plus 2OH minus ion, this is aqueous medium. So they are going to be what? That is Arrhenius base. The substances which are able to donate OH minus ion in water, that is base. The substances which are able to donate H plus ion in water, that is going to be acid. Are you able to understand this?
Yeah.
Okay. Can I erase
I
this?
think this is the same concept as the acid one, except it's just with OH minus now.
Can you please say again, please?
Sorry, I was just saying, I think so. My understanding of this right now is that it's the same concept as the acid one, but instead of H plus, we have OH minus.
Mm-hmm. In case of bronze state, it is little bit different, little bit. If you can I delete it? Can I
Yeah,
erase
yeah,
this?
I have written. Yeah.
Okay. See, yeah, one last one. You last part is there. Okay. Reaction between. Okay. This is because important. This is the difference is there. Reaction between what they are saying. Arrhenius acid and base. Arrhenius acids and base. Acids and base. See what is happening here. In all the three concepts, this reaction is different. Okay. So what they are saying, reaction between, it gives. Okay. It gives what Arrhenius acid plus base, it gives salt plus water. It gives salt and water. Okay. That is what the important thing is there. Arrhenius acid react with Arrhenius base, so it is going to give salt plus water. Let's have a look over it. So suppose I am having Arrhenius acid HCl. This is going to be Arrhenius acid. Okay, Arrhenius acid. Now, just now we wrote the Arrhenius base. So many bases we wrote here. So I am taking this one is Arrhenius base. This one anyway. So if you are taking that is NaOH. So what it is going to happen here? This NaCl combine. So here it is going to give what NaCl. NaCl that is going to be salt, and another is there H2O. So it is going salt plus water. So any of the base combined with Arrhenius acid combined with the Arrhenius base, it is going to give the salt plus water. Suppose I am having that is CH3COOH, and you are taking that is KOH, you can take KOH. So what is going to happen here? This is H, and here is this is OH. So this is HOH combined to give here is the water. Okay. And another what is going to give, that is CH3COOK. So that is, it is what? Salt. Plus minus where is there in the same compound, they act as a salt. Okay. This is potassium it is acetate. This is what is known as potassium acetate. So ACETATE. Oh, wait, no, let me read.
Mhm.
ACETAT. Can I erase this one?
Yes.
Okay, thank you. So here. Next one is concept number 2. Bronsted and Lowry. LOWER, Lowry. Concept of acid base. Concept of acid base. This one more name is there. In your book itself, it is given. Okay. What is there? Conjugate acid base concept. Conjugate acid base concept. This is also okay. This is what moreover understanding based this concept. What they are saying. Okay. So if you are talking about Bronsted acid, okay, simple you can say Bronsted acid. So what can be Bronsted acid? The substance which the substance which gives H plus ion, gives or donate H plus ion, donate H plus ion,
Mhm.
H plus ion. In bracket 2 base, this is why my own statement 2 base, donate H plus ion is called, okay, is called Bronsted acid, is called Bronsted acid. What is the condition? Here the in the Arrhenius case, Arrhenius, let's go back and see the Arrhenius acid. What the Arrhenius? They are saying Arrhenius acid, the substances which gives H plus ion in water. Here the condition is little bit different. Yes or no? In water. But here you see here they didn't mention any water. The substances which gives or donate H plus ion to base. To base may you may be understanding latter part is called Bronsted acid. Okay. So suppose HCl is there. HCl generally exists in the form of gas. Yes or no?
Yeah.
So it is also going to ionize to give H plus, okay, and here is this is Cl minus, okay. So it is acting as
Mhm.
a acid, okay. This is the what acid because it is the gaseous form. So in the gaseous state also, it is going to dissociate in H plus ion and Cl minus. So it is acid, but acting as a bond state acid. Now, if you're talking about the next one, let's go for the bronze state base. Bronze state base. Now see, bronze state base. Here saying the substances, what will be there? The substances which, what is there? Which takes H plus ion. See the point. The substances which takes H plus ion is known as bronze state base. Is known as bronze state base.
So which receives the H plus ion.
Yeah. So what they are saying? It is taking H plus ion. Giving H plus ion, bronze state acid. Taking H plus ion, bronze state base. Example you see. Suppose I am having NH4 plus. Sorry. NH3 is there. Okay, NH3. You see, NH3 is there. Here is lone pair electron is there. So what is happening if it is H plus is there now? So what it is going to do? It is going to attract H plus ion. So it is the NH4 plus. Yes or no? NH4 plus. So it is bronze state base. How bronze state base? Bronze state base H. It accept. What it is going to do? As it accept what? H plus ion. Yes or no?
Yeah.
Okay. So giving H plus ion is the what is known as bronze state acid. Taking H plus ion is bronze state base. Let's try to understand this. Suppose you are having that is H2O. Here is lone pair electron is there. Okay. Yeah, I am having the H plus ion. Okay. So what it is going to give? This lone pair electron is attracting H plus ion. So it is going to give H3O plus ion. So what is this? What is this H2O? How it is acting as an acid or base?
So it's acting as, so it is going to receive, so it's acting as a base because
Uh,
it's receiving the H plus.
hmm. Thank you. Act as a base as it attract H plus ion. H plus ion. Okay, got it.
Yeah.
Acha. Sorry, one note I am writing here. You try to understand this one. Sometimes student get confused. Okay, so what confused the part is there. Uh, in bronze state base, what they are saying in bronze state base, okay, H plus ion is you know is at product side. H plus ion E. Oh no, H plus ion is at reactant side. Reactant. It is going to be reactant side. Okay. This is from your book one. In bronze state base, H plus ion is at reactant side. Okay. Very left. Very left. It is left side. Okay. In second point, what they are saying in bronze state acid, H plus ion is right side. Is at product side, or you can say right side. Okay, you can say right side also, right side. Now you put it out here, very right. So you see in case of bronze state base, H plus ion is at reactant side. So here what is there? This you will apply here. So this you are saying that is H2O is base. So H plus ion is what? Reactant side. Yes or no?
Yeah.
Okay, next one. Here HCl is acid. As it donate, as it gives what? H plus ion. So here is in the acid H plus ion in the product side. Yes.
Yeah.
So here you see this is what the concept from your book only. Okay, jumble book. So this is what the point that you need to keep in mind.
Okay.
So can I erase this?
Yeah.
Okay, thank you. Now uh, let's see. Conjugate acid base concept. Conjugate acid base concept. Acid base concept. Okay, this is there in your syllabus. You please check it out. Conjugate acid base. Okay. The acid base pair, they are saying the acid and base pair, which are differ, which are differ only in H plus ion. H plus ion is known as what? Conjugate is known as conjugate. What is there? Is known as conjugate acid base pair. Acid base pair. It means acid have conjugate base. Acid have conjugate base. Okay, and
Okay.
base have conjugate. Base have conjugate acid. Base have conjugate acid. This is what the concept. Its definition is, although it's look little difficult, but the answer example is very easy. See, HCl I have taken, and then I have taken NH3. Correct? You see, HCl here a lone pair electron is there. Okay, so this lone pair electron is going to accept H plus ion, so it is converting into NH4 plus. Now, see, we out of these HCl and NH3, okay, which is giving the H plus ion? Hmm. Which is acid? If I ask which is acid, so which will be their acid?
So it will be HCl.
HCl, it is acid. Okay, acid. As it donate H plus ion. Yes or no?
Yeah.
Okay. It is base. Why it is base? As it accept. Okay, as it accept what? H plus ion. Yeah.
H plus ion.
Okay. Now you see when the HCl donate H plus ion, so what it is going to form? This is Cl minus. Yes or no?
Yeah.
Okay. Now see, in this case, now HCl, I told you, acid have conjugate base, means Cl is converting, HCl is converting into Cl minus. So this is going to be conjugate base. See, this is going to be conjugate base. Why? Because HCl and Cl are differ only in H plus ion. Yes or no? They are differ only in H plus ion. So acid, it was acid, so it is converting into what? Base. Is it okay?
Base.
Now HNO3, you talk about HNO3. Here you see, in case of HNO3. So what it is going to happen here in case of HNO3? So ammonia is accepting of H plus ion. Yes. So it was base accepted. So that is going to be conjugate acid. This is going to be conjugate acid. So that is what the concept is saying. That is base have conjugate, no, base have, it is open only. See, go and check. Acid have conjugate. Acid have conjugate base and base has conjugate acid. Will you be able to understand this?
Yeah.
So please make a note of it. Boys, please go sit inside 10 minutes. अपना कपड़ा वहां से उठाओ तो नहीं हो. Completed?
1 second. So just 1 more minute. I'm just writing.
Oh.
Noted.
Noted. Okay. So this is the conjugate acid base pair. Okay. I'm giving you the questions here. Right. The conjugate acid base pair, conjugate acid base pair from following equation, from following equation, from following equation. So one equation I'm giving you, okay? Suppose I'm taking you H2O and let's have NH3, okay? H2O and NH3, this one. So let me, you kindly tell me what will be our answer.
This will be that NH3 accepts a proton from the H2O, so it will form NH4 plus, which will be the conjugate acid.
Thank you so much.
And since H2O will donate NH plus ion, it is going to become OH minus, which is the conjugate base of the reaction.
Thank you. So this is the going to be conjugate base. This is the conjugate base. This is acid and this is base. Okay. Which is it? This is the called Bronsted acid. You know, because here medium not required. Bronsted acid. This is going to be Bronsted base. Now they are saying acid base pair they are asking. So how can you write? So acid and conjugate base. Acid conjugate base pair. Acid conjugate base, which is the acid. So if you see H2O is acid and its conjugate base is what? OH minus. Yes or no?
Yes.
Acha. Base plus conjugate acid. Base plus conjugate acid. Okay. Base plus conjugate acid. So base is what? NH3 and its acid is what? NH4 plus. Can you be able to understand this?
Yes.
Okay. Can you please make a note of it, please?
Yeah. Not really.
Yeah, thank you. Now, next one. Next part you go. Reaction between Bronsted acid and base. Bronsted acid and base. Bronsted acid and base. Okay. Bronsted acid and base. What is the reaction between Bronsted acid and base? So if you talk about the Bronsted acid and base, it gives, what is going to give? It gives what? Bronsted acid base react, it gives conjugate acid and base. It gives conjugate acid and base on reaction. Are you be able to understand on reaction?
Yeah.
Okay. Earlier, see what we were studying. Here they are seeing Arrhenius case, man. Here what is there in Arrhenius case? I just want here it gives salt and water, salt plus water, right? In case of Arrhenius acid base, but here you go. What is going to give here? It gives conjugate acid and base. Suppose if I am talking about HCl, okay, and you take that is H2O now, okay. So this is the H, okay. Now so it will form that is, this is taking this one. So it is forming that is H3O plus and plus Cl minus. Cl minus, it is going to be base. Which base? That is conjugate base. Because, and this is the acid. So acid have conjugate base, right? Now this is acting as a base because it accepted H plus ion. So it is going to be this one. So it is conjugate acid. Conjugate acid. So what they are saying here, see, this is the acid, this is base. Okay, so many reactions are there, but here it, the basic one is this one. Got it? This one? Got it?
Yes.
Okay. Now, what I'm telling one more problem here. If I will say note, okay. Some substances, okay, here they are talking some substances can act as both acids and bases as they have capacity as they have capacity to accept H plus ion, H plus ion, as well as to donate, as well as to donate OH minus ion, to donate OH minus ion, OH minus ion. Now see, here you see H2O if you are talking about HOH. So what is happening? It is ionizing to give H plus ion plus OH minus ion. Okay. So both things are there. So it can be the, the substance, it can act as a both acid as well as base, as they have capacity to accept lone pair ion, are called amphoteric, are called amphoteric acid. You know, this is going to be amphoteric acid.
So they can technically accept and donate H plus ions.
Yeah. Now here you see, now in this equation is not going to explain this one. This is going on. This is the, bronze. This is the amphoteric. This one is, it is amphoteric, 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 according to Arrhenius. According to Arrhenius. Yes, no. Arrhenius say acid give H plus ion, base give OH ion. The both it is capable to give. So that is the what amphoteric, according to Arrhenius. Yes, no.
Yes.
Okay. Now see, H O H. Another you see H O H. Right. Here is lone pair is there. This is also lone pair. This is also lone pair. Okay. What is happening? This is taking H plus ion here. And so this bond is shifting here. So see, it is what forming H O. Here is now H. Here is now H. This is positive charge. Okay. And here is what is going to form OH minus. Okay. So this is converted into OH minus, and this is converted into this one. So see, the first one, this one, and this is second one. The first one donated H plus, yes or no?
Yeah.
So donated H plus, so acid. This is going to be acid as it donated H plus, as it donated H plus. And this is base as it accept H plus, as it accept H plus. Yes. What is this one? This is conjugate acid. Conjugate, okay, acid of H2O, H2O base. And this is conjugate base. This is going to be conjugate base of H2O acid. It means that is H2O is amphoteric in this equation. Amphoteric in this equation. In this equation.
That proton H plus ion simultaneously.
Amphoteric in this equation according to what concept? According to Bronsted concept. So last one is the amphoteric because of the Arrhenius concept, but here it is because of the Bronsted. Are you be able to understand this?
Yeah.
Okay. Can I erase this?
Yes.
Okay. Now the last part we are going to is Lewis acid base concept. Lewis acid base concept. Okay. Lewis acid base concept. It's quite short. Okay. So it's short. The here we are going to write that is Lewis acid, and this is we are going to write that is Lewis base. So if you talk about the Lewis acid, they are lone pair acceptor. They are the lone pair acceptor. If anything is going to accept lone pair, they are going to be acid. Like H plus ion can accept lone pair electron, CH3 plus, all the positive charge. Okay, they are going to be the acid. Okay, another condition they are saying BF3, BCl3, BH3, they all are going to be acid. AlH3, because they have backend incomplete octet. You see, they are having incomplete octet. 6 electron is there. So they are going to be acceptor of they are the lone pair, they can accept. So they can be act as a acid here. They are saying they are what? They are lone pair donor. Lone pair, they are lone pair donor. Why? As what is, no example I am better, I am writing they are lone pair donor. Okay, let's write the example. See H2O. In this concept, according to Lewis concept, it is base. Why? Because it donates the lone pair electron. If I am talking about the NH3, it has capacity to donate electron, so it is base. All the negative charge, OH minus ion, it can be base. Cl minus ion. So all the negative charge, what you can write, that all will be the base. You know, PH3. This is going to be base. H2S, lone pair electron. They all are base. Why? Because they are capable. Negative charge, you know. So negative charge or lone pair containing a species, you know, lone pair containing species. Okay, R Lewis base, R Lewis base. Are you be able to understand? R Lewis base.
Yes.
Here, what we can write, that is positive charge. Okay, positive charge and incomplete octet species. Incomplete octet species. Octet species. R. What it is going to form? R Lewis acid. Hmm. So little bit you need to be practiced on it so that it will be the very much clear. Little bit practice required on it. Yeah.
Yeah.
Okay. Can you make a note of it, please?
Yes. 1 second, I'm just writing it down.
Hmm.
Okay, I got it.
Thank you. So now let's move on this one. Lewis acid base reaction. Lewis acid base reaction. So what is formed? If it is reacting, it gives salt. Okay, it gives salt. What kind of salt it is going to give? Okay,
NaCl.
coordinate. It gives coordinate. It gives coordinate salt. That is what coordinate salt. It is going to give, that is coordinate salt. Okay, that you have to give. That is coordinate bond form. That is coordinate bond form. Coordinate bond form. Let's have a look. Suppose I am talking about NH3. Okay, it is the Lewis base, LB, Lewis base, because it is having lone pair electron. This is H plus. This is Lewis acid. Why? Because it is positive charge. So what it is going to? It is going to donate these 2 electrons. So it is going to form, that is NH. So here you can write the diagram like that. Here is hydrogen is there. Here is hydrogen. This is hydrogen, and this the coordinate bond is formed like that. H. So there will be the positive charge is going to form as a whole here. Or you directly we can write that is NH4 plus. But this is what is bond name is. This is what is bond or name. That is going to be coordinate bond. Yes, yeah, no.
Yeah.
Yeah. Can you please make a note of it?
Got it.
Hmm.
Yeah, got it.
Okay. Here you see NH3. If you talk about NH3, this is the Lewis base, and this is electron deficient. So it is going to be Lewis acid. So what will happen here? What will this is going to donate the lone pair electron to it. So it is going to form the compound like that, NH3 coordinate bond BH3. Okay, this is going to be salt. Okay, and this is the coordinate bond. What kind of salt? That is coordinate salt. Coordinate salt. Can you please make a note of it?
Sorry, could you repeat that? So if it's if BH3 reacts with NH3, So it is going to then form a coordinate salt.
Yeah. Can I explain? Can I explain in detail?
Yes, please.
Okay. See, BH3 if I'm talking about, so boron is having 5. So how many valence electron? That is the 2, 3. 3 valence electron. Hydrogen is having 1, so it is 1 valence electron. So if you are making the structure, so 1, 2, and 3. And hydrogen, you can see here, hydrogens are there. So that is cross, this is cross, this is cross. So let's have a look over it. How it is, how many electrons are there with the boron? How many? That is the 6 electron, 6 electron. Okay. It is completing the duplet here. It is completing the duplet. Yes, yeah, no. So this is duplet. Now next one is we are having the ammonia NH3. So you see NH3, if you talk about nitrogen, right? So nitrogen, it is having the 7. So 2 and 5. Hydrogen going to be 1. So I'm writing here is the nitrogen. So 1, 2, 3, 4, 5. Hydrogen, here is hydrogen, here is hydrogen. So this is the cross, here is the cross, here is the cross. Students, you can make it. This completing the octet here, no issue about it. This completing octet. Here is this one is there. Here is this one is there. This also completing the octet. Now, what is going to happen here? Boron not completed octet, no? Boron not completed, but nitrogen completed 1, 2, 3, 4, 5, 6, 7, 8. So what is happening? The boron, how it complete the octet here, see. It takes this electron. No, another color, I am changing this color. I am taking. Mhm. So boron, how it is completing the octet? It is taking the 2 electron this way. Okay. So now boron, you see 2 to 4 to 6 to 8. Yes, yeah, no.
Yeah.
Nitrogen also completed the, but in this process, what is happening? Both the electron is being, both the electron is of nitrogen. So it donated this. It donated to boron. Yes, yeah, no.
Yes.
So what is happening here? You see, this is the BH. Here is hydrogen, downside hydrogen. It is taking the electron pair. So this is the arrow. Here is the nitrogen. This is the hydrogen. Here is hydrogen. Here is hydrogen. Can you be able to understand this one?
Yeah.
So this is what is the coordinate bond. Coordinate bond. Yes.
Yep. Got it.
Now understood this one. Is it clear?
Yes.
So this was the acid. Why acid? Because here you see the lone pair electron accepted by boron. Here you can see. This is base. No. Why base? Because lone pair electron is donated to Lewis acid. Yes or no? Lewis acid. Acid. H. It accept lone pair. It accept lone pair. Accept lone pair. You can see here in the circle accepting. Lewis base H. It donate as lone pair. It donate lone pair. Yes or no?
Yes.
Can you make a note of it, please?
Yeah. 1 second.
Mhm.
Okay, I made a note of it.
Now what we are having in your syllabus, I'm checking your syllabus next one. Okay. They are saying the types of their acid they are talking about. Okay. So let's see. This is okay. Types of acid, types of acid, types of acid on the basis of H plus ion donor, H plus ion donor. Okay, donor. So they are talking about 3 types. First one is monoprotic acid. This is what monoprotic acid. Okay. Next one is diprotic acid. Diprotic acid. Okay. And last one is polyprotic acid. Polyprotic acid. So what is their monoprotic acid gives, what is gives only one H plus ion, only one H plus ion. Okay,
Also
example
only
you can
one
write
bond.
that is HCl. Okay, H2O. Okay, HBr. Okay, HClO4. Okay, HClO3, HNO3, like that, etc. Only one H is there. Okay, next one, diprotic acid gives 2H plus ion. You know, this is going to gives 2H plus ion. It is going to give, that is 2H plus ion. Okay, like if you are talking about H2SO4, okay, H2SO3, you know, this type of acid is there. Okay, next one, polyphytic gives 3
Mhm.
or more, gives 3 or more H plus ion. Okay. In H2SO3, there is also there H2S2O7. This is there. So many are there. You know, so many are there. I'm writing few of only. Okay, gives 3 or more H plus ion, like H3PO4. Okay, giving H3PO4. So you see this H3PO4 giving, that is what, 3H plus ion plus
Three H plus
PO4
ion.
3 minus ion. So 3H plus given now. So polyportic acid or triportic acid. Yeah, H2SO4, just now we have seen 2H plus ion plus SO4 2 minus ion. So 2H plus ion giving means what? That is the diprotic acid. Yes. And here what it is going to give, here you can see already you have seen H plus ion plus ClO4 minus ion. So one H plus ion, that is monoprotic acid. Can you please make a note of it?
Just 1 second. So just to summarize, monoprotic donates 1, diprotic donates 2, and
Hmm.
polyprotic donates more than 2.
Yes. Is the examples are clear to you?
Yeah.
Okay. Please write down the this one. This from the your books only. You know, jumble book. What you send now? From these books, they have given the monoprotic, diprotic, polyprotic. So when you read this one, you will be able to understand.
Yeah.
Hmm.
Okay.
Can,
I made the note.
can I erase?
Yes.
Okay. They are saying oxy acid. Okay, oxy acid. What are oxy acid? So they are saying acid containing, okay, it is acids containing oxygen. Okay, acid containing oxygen, or they are saying acid containing oxygen, or okay, oxygen containing anion. Oxygen containing anion, oxygen containing anion. Now see, like see H2SO4, although it is diprotic acid, but this is also known as oxy acid. The oxy acid, this is, if you are talking about HNO3, okay, monoprotic acid, but this is comes under what, oxy acid, because it contain what, oxygen, or oxygen containing anion. If you ionize, so what will give, that is SO4 2 minus now. So this is anion is oxygen containing, yes or no?
Yes.
Okay, if suppose this one you are taking HClO4 minus, so if it is ionizing HClO4, so what it is going to give, it is going to give H plus plus ClO4 minus. So again, it is going to be oxy acid. Yes or no? Because all is
Mhm.
having the oxygen. Yes.
Yeah.
Okay. Can I erase?
Yes.
Okay. Now, halic acid. Hydro. This is hydro halic acid. Halic acid. Uh, or that is hydrogen halide. Hydrogen halides. This is hydrogen halide. This is like that. That is halogen containing acid. Halogen containing acid. Halogen containing acid. So they are halogen containing acid. So that is, you can write, that is HCl, HBr, you know, HI, you know, uh,
Mhm.
these are they are the halogen containing acid. This is, these are the, because here HCl, BRI, HF is also there. So they are the what? HFCl is the acid. So they are the hydrohaloic acid. Can I erase?
Yeah.
Okay. Next one is what is there? Sorry, which we have to study. That is strength of acid and base. Strength of acids and base. Strength of acids and base and pH calculation. So next heading will be pH calculation. So these things I'll be explaining in the next class. Why? Because the today already the outside of my house, so many students came. Okay, for the class only. So, acha, can we? What topic you want in the next one? Can you please tell me? This we
Next
will
class, I
continue.
think, we will continue this only strength of acid base and pH calculation. And yeah, I think we'll continue with acids and bases only.
Okay, okay. Salt hydrolysis will be able to do in the next class. So thank you very much for being on Saturday, changing the timing. Okay. So
No problems. Thank you, sir.
okay. Bye. Bye. Take care. No.